the YouTube Live, for some reason, they changed the once again the interactions in the live control room. So I've been getting some issues there. Okay, hopefully this will all go well. Let me change my screen. All right, can everyone see my screen?
Yeah.
Sweet, perfect. Okay, now hopefully I see the stream is also working. All right. As I was saying, today I thought it would be nice, based on some discussions that Michael Fiano and a few of us that was here last week were talking, to get a basic application kind of like, started. It's going to be kind of a live coding session, so folks watching on the YouTube stream as well as folks here, feel free to ask questions, provide some comments, suggestions, and so forth. The One of the common questions that have been asked across some of the uh, YouTube streams that we've been doing this past year and so forth has been dealing with writing applications and so forth. One of the things that was brought up actually has a few days ago was related to building executables using ASDIF and building applications. So I thought I would combine all those kinds of questions into kind of a simple application that we could end up just building. One idea that was suggested, and Michael, I was hoping that you could provide some insight into this. I was looking into Kaitai struct, and I was thinking that we may want to, start with that and maybe create a simple application using just creating a simple binary format and then reading off of it, like maybe like what we were trying to do before with FLAC. I don't know what your thoughts are on that.
Okay. Yeah. FLAC is a very simple format, at least the metadata portion, without doing any of the actual decoding. I mean, just parsing the types as they appear in the format is laid out pretty simple. So that might be one of the simpler ones I've ever parsed.
Okay. Other suggestions are open for other applications. We could go through them in other streams. I was thinking that we'd start with that just because, one, it would be pretty easy for us to go through, given that the FLAC documentation is fairly complete, and I think it'll be pretty straightforward. Last time I remember going through it myself, but let's get to it. So the first things that we probably want to do is obviously generate our project template. I normally use a a project generator by Fukumachi-san in CO project. Other folks, I don't know if you guys use Quick Project or not. The reason why I use CO project for project generation is mainly because of the fact that I tend to use also a lot of his testing libraries, and this actually fits well into actually using his testing libraries, particularly Rove, for unit testing and so forth. So we'll go ahead and create our project. Let's call it, let me just go ahead and put it in my Roswell local projects directory.
Did you say Rove or Prove?
Isn't Rove the successor to Prove?
Yeah, but it's pretty incomplete still. I mean, there's not even a way to test multiple values yet.
I don't know if I think CO project uses Rove behind the scenes, but we could always add Prove and use Prove instead. We'll. I mean, I'll show you. I mean, it's whatever's in from Make project that gets automatically generated is the one I use. I think it is Rove, but it might be Prove. I don't know. I thought it was
mainly
Rove.
only use Prove or Shinmera's Parachute. I kind of go back and forth between the two. Both of them are very complete.
So let's just do.
Rove is lacking a lot, I would say.
Rove is lacking a lot. Okay, so let's go ahead and see what happens when I create this simple, let's call it FLAC metadata demo. We'll add a couple of things here. We'll say it depends on do we want to use? I'm assuming that we'd want to use Alexandria and Serapium. So I'll go ahead and add those in there. There was this this library that I think you wrote, right? That does some basic binary parsing.
Yeah, I kind of don't like that. I mean, it's only a couple functions anyway. I would just recommend writing them.
Okay, that's fine.
It's not very well made.
All right.
It was only meant to be like a simple little utility library with a couple functions anyway.
So just to see what was generated so folks can actually see what unit testing library we're using, I have to go into the actual ASD file, flat metadata demo. And yeah.
I have a little question if you may. Hello?
Hello?
Yeah, a little question, if I may.
Sure. Yeah, go ahead.
Yeah. Have you actually used a lot of utility functions from Serapel?
I've used, I think
I know that library pretty well. I've used quite a bit of it. I prefer not to use it only because it brings in about 40 dependencies.
Oh, yeah.
And it's pretty heavy when, if you're writing like a little small utility or like a little small library and you're bringing in 40 dependencies just to like use maybe one or two utilities from Serapium, it doesn't really make sense.
It's getting deleted.
Unless you don't mind that it's big, then it makes sense. I do.
It's getting deleted. I only use one or two functions from there, but that's only because of the fact
that... It is a very good library, though. It just brings in a lot from other stuff.
Yeah.
All right. Okay, thanks.
So let's go ahead and load this guy into our Lisp image right now. Data demo. Okay, sweet. Okay, and to answer your question, it looks like it is Rove. I could change this to prove instead. And then
I wouldn't change it. I'd just leave it because I think you got to mess with the like ASD configuration to use prove. There's like stuff you have to add to the ASD file and stuff. We don't need to do testing right now. That's a whole process in itself.
Right. Okay. So let's go into source main Lisp. All right. So for folks who haven't actually seen libflax format, I will post both in the chat on YouTube, on the YouTube stream, as well as the Hangouts, the documentation where it is located. It is the format specification. Okay. So this is the format that we will be covering. And let's go ahead and post this as well on in the YouTube stream. Alright. So this specification is fairly simple from the metadata perspective. I don't believe we're going to be touching the frame struct at this time because we're going to be just handling some of the metadata.
Yeah, that gets pretty complex.
Right.
Huffman encoding and yeah.
Right. They'd rather not get us into that situation, right? So just make sure I have my FLAC example ready and waiting. Because I have yes I do. Alright, perfect. just go ahead and actually name this symbol.flag. Okay. All right. So just pull this up here too as well, so I can actually have it as another screen as I go and code through this.
So let me see here. So I believe, if I recall correctly, everything in FLAC is either big endian or little. Okay, it's big endian, so we don't have to worry about endianness at all.
Okay.
So what we should start with is writing a couple utility functions for being able to, say, read an unsigned integer in big endian format of an arbitrary. Of an arbitrary number of bytes, and like stuff like that, like reading an octet vector, reading a string, like the primitives that we need to be able to parse out.
Right. So let me just go into here. So we need to be able to read off. So let's see. I guess we should go ahead and start with reading. Reading an octet, I guess. Let me see here. Stream consists of. It has the magic number, which is 32. It has a metadata block and a metadata block star. Okay, so we need to first write reading an unsigned, I guess an unsigned integer in big endian, but that's already done, I think. Hold on. From a stream, right? We're reading it from a stream. Unsigned.
I would pull in the fast.io library. That's a good library for reading from streams and octet vectors efficiently.
Got it. Let me go ahead and add that as a dependency in here.
Yeah.
Fast.io not found. Did I spell that wrong?
Let me
just go
see
and
what
see.
you got. Where did you type it in? Can't see. Oh.
You want me to increase the size?
Oh, it's fast-io.
Okay, so before we continue, let me go ahead and just for the time being. Okay, so I gotta go and remember now how to actually increase the font size for Emacs.
Control X, Control plus. Or I think it's equals, actually. You don't hold Shift.
Got it. Okay. So that's
a file increase. It will only affect one file. Like, even if you switch to another buffer in that same window,
yeah, I figured.
Small size. So there is a frame zoom. It does require pulling in a package that's not enabled by default, though.
Okay, so let me, for the time being, do this side-by-side comparison so I can actually have folks be able to read stuff in my buffer. And all right, let's see if this works. Okay, so now I have that. Okay, so we need to, let me go and look up the fast.io documentation because I haven't used this library before. Okay. static. Okay, so we can write a couple of. I don't know if we have to do this, but looks like we should. Write a couple of def types following what the fast.io documentation says. I don't think octet and octet vector is defined, so octet unsigned byte 8. Right, 8.
Do you have any sample FLAC files?
Yes, I do have a sample FLAC file. I took one of some MP3 and just converted it to FLAC the other day.
Oh, well, that might not work.
Why not?
Because it might not have any metadata.
Well, let's see if I... well, I wouldn't be able to know unless I open... what's the way I could do this? Sorry, my let's see if I could do it. If I could just do a binary dump, it would be fantastic.
Just load it up with the FLAC metadata that we already wrote.
Let's see. Do I have that project somewhere? I should.
It's in Quick Lisp. Well, at least one of mine is in Quick Lisp. I parsed FLAC like 3 different times, just in Common Lisp alone.
Fantastic.
And other times too.
Okay.
Format.
Okay, so you said it's in. Okay, what is
FLAC-metadata. Then it should just be load file. We'll do a colon and then a tab. I'm going to see what it pops up with. Well, get rid of the load part.
It says load file.
Yeah, get rid of the load part and do a tab.
Okay. Dump file.
Dump file. That's it.
Okay.
And
file
just
name.
give it the name of the file.
Okay, let me just move this into a different location here. Looks like we have something.
Okay, cool. We have quite a bit. Nice.
Okay, perfect. All right. At least we have a final result. All right. So, give me just 1 second. Right. Let's see here. So why is this complaining? This should have worked based on...
We don't need that.
Oh, we don't? Okay.
No.
I'm just trying to follow, kind of make it a little easier in terms of reading through it. I mean, this is kind of nice little thing to do, right? Having that, but okay.
So, to use FastIO, it basically allows reading. Well, it buffers octets. So, like, as we're reading each chunk of the FLAC stream, we could, like, instead of like the normal way to read a stream is, to read X amount of bytes at a time, right?
Right. That's right.
If we did that with this, we'd have to read, like, say, a uint32 at a time. If we like whatever primitive we come across, we have to read that and then parse the data out of it. Whereas with FastIO, what we could do is, since everything is stored in a chunk, which is maybe 100 or 1,000, couple thousand bytes at a time, we could just read all that into a buffer. So it's already in memory, so we're not reading it off the file stream. And it turns out to be a lot faster. And it has some nice abstractions over that. So first thing we probably need is to write a little simple macro for like something called like with buffer or something like that. So anything within the context of that is going to read out of FastIO.
Got it. With buffer, and I guess it should be the file name, probably.
No, it should. Well, we need to specify if we're reading off of a stream or a sequence. So I would do inside that lambda list, I would do another set of parentheses, like two open. Get rid of that stream. Yeah, I would do and key stream sequence.
Okay.
And that'll let us be able to specify which one we mean. And then after that, we can do and body.
Right. And in here, we do with FastIO.
No.
Right?
No. We want to... well, we need to... Let's see. We need to... we want a special variable called buffer first. We need something global to hold that in.
Okay, so I'm guessing this buffer will be just a
Just
gen
do
sim,
def bar.
right?
No, we want to do a def bar. No, I mean up above the macro. We'll finish that in a second. Def bar buffer. And that's just gonna be, that's not even gonna be initialized. Just leave it as nothing. Yeah.
Right.
And then in that we want to probably gensim, do the backtick. Or I mean not the backtick. I'm sorry. Yeah. Get rid of the backtick. I'm sorry.
Yeah, I was like, wait,
we want to do Alexandria with gensim.
Oh, got it. Alexander, you know what? Let me just do this before I forget. Make it a little easier for us. Names a what? Unbalanced. Oh, right. Here we go. Much better. Okay. A with the
gensims. Bytes.
And we need
bits.
Bytes and bits. Okay.
And that's it for gensims. And then after that, you can open up your backtick and do let comma bytes. Well, inside a and that is going to be FastIO make input.buffer.
Make input.buffer?
FastIO make input buffer. Yep.
Okay.
And it's going to take
the vector, which is our stream, right? No.
Keyword arguments vector. And that's going to take comma sequence.
Oh, it's our sequence. Got it. Okay.
And it's also going to take :stream, and that's going to be our stream.
Right.
So depending on which one we pass in here, yeah, that'll work. Okay, so that's our bytes. We also need bits because, well, fast.io only allows reading bytes at a time, but we do want to be able to read only a certain number of bits off the stream.
Right, for like the meta block header.
We don't want to read a byte's worth just to get a few bits, because then we're going to lose them for the next time we go and read some more bits or more bytes or whatever. So we do want to bring in another library for reading bits.
Okay.
And a friend of mine wrote a good library for that. It's called bit.io, with no dash, just bit.io.
Okay. Hold on one second.
Probably bring that in too. Makes it a lot easier.
I have this already open. I'm just like adding it to
.io for bytes, and we'll use bit.io for bits whenever we need to read bits. And that's why this macro is here. So it just abstracts over that. We never need to worry about these two libraries in the back end.
I'm going to go ahead and just load that library manually for now, but it's already in the ASD file.
Yeah.
And then we can just do that. And then,
because there's certain things in FLAC that only reads like a less than a byte worth, basically.
Yeah, I think the meta block header has separated it based on the.
So we don't want to read a whole byte and then cache the extra bits and work with LDB and everything like that. We'd rather just read however many bits we need. It's
right. So this is that one. This is position 0.
Okay, so close that and do another binding called bits. Well, inside that let. Yep.
Bit.io.
And that's gonna be let me remember. Bit.io make bit.io. And it's gonna take
is our octet stream
your comma bytes.
Yeah, that's right. Wait, so this should be a let star then, right?
No, it doesn't need to be.
If you're referencing...
Oh, yes it does, I'm sorry.
Right.
Sorry, I was not thinking. So it takes comma bytes, and the second argument is going to be a function, so sharp sign quote fast.io fast read byte.
Fast read byte, okay. And then I guess the same will go. Oh, wait, sorry, no parentheses, sorry. Fast.io, fast read byte. And then for the read sequence, it's going to be, I guess, fast.io read sequence?
No, it's going to be bit.io read sequence. But I believe we want to, let me think here. It's actually going to be %bit.io read sequence. It's a low-level bit reading sequence. Yeah, I remember now. Okay, yeah. That one.
So
bit.io.
Is it %bit?
It's been a while since I used this library.
No, it's bit.io %read sequence. That's what it is, right?
No. It's %bit.io -read -sequence. Oh, you know what?
It's not showing up in
Never mind. Okay, just call it read bit sequence. We'll define this, actually.
Okay.
We'll define this. I forgot that I actually do define it in another place.
Okay, so this is defined. All the defaults are good, but byte endian is set to little endian in this signature.
Where do you see that?
So bit endian, if you look in the in my mini buffer, unfortunately.
Oh, that's okay. We'll fix it.
Okay. I was just.
That's yeah. See, there's a difference between byte endianness and bit endianness, And we actually want little bit endian this, so that's perfectly fine anyway.
No. So bit endian is set to big endian. Byte endian is set to
yes, we want
endian.
big endian for bit endian, and we want little endian for that's perfectly fine.
Okay, good. All right.
Because we're only going to be ever reading, less than a byte's worth anyway. So byte endianness doesn't mean anything for reading bits.
Got it.
As far as I know. Okay, so with that out of the way, let me see. We need one more binding in our let statement, or let expression. And that's to bind our special variable.
Right.
We want to bind our star buffer star. And we want to make an instance of some class we haven't defined yet called buffer.
Right.
And just pass in as keyword arguments, bytes equals bytes and bits equals bits and sequence. We'll get to the sequence in
bytes is bytes. Bits is our bits.
And we also want to do stream and sequence.
Stream is our stream. Okay.
This, you know what? This is probably going to get long. So why don't we just put like I'm just trying to make it easier for the stream watchers. Can we move the make instance and then where it says quote buffer? Can we like make that on a new line? So it's,
yeah, sure.
Stream and sequence are going to get kind of long.
Oops.
I think.
Hold on.
That way it wraps nicely. Well, you don't have to do that.
Is that on a new?
Just put buffer after make instance on a new line.
Okay.
Yeah, that way we get more space for everything else. And then re-indent that stuff.
Got it. Hold on.
That should be good enough anyway.
Give me a second. I don't know if I could just do this here. No, it's not going to allow me because it's I have to
and put bytes after buffer. You don't really want your first keyword argument after class like that.
Yeah, right.
So everything lines up. Okay, cool. So now stream is it's not gonna be comma stream. It's gonna actually be fast IO input buffer vector of your bytes.
Input
buffer vector.
Buffer vector, right? Yeah, got it. And of my bytes, you said, right?
Oh, I'm sorry. That's actually sequence. Let me give you the stream one. That's for sequence.
Oh, okay.
Stream is going to be input buffer stream of your bytes, and sequence is going to be input buffer vector of your bytes.
Got it. Yeah, fast IO input buffer vector of the bytes. Okay.
Oh, what happened to your indentation there?
It got messed up because I've been let me do something here. Let me see if I could. Okay.
Oh, that's better. We should probably use that anyway.
Right.
I didn't know you had word wrapping. It looked kind of weird for a second.
I don't know when I turned it on.
That's all right. Okay, so that's going to be our macro. The only thing we got to do is return comma at body, because anything we evaluate in that context is going to have those let bindings around it.
Right.
So what we're doing here is, we're dynamically binding the buffer, the star buffer star, to be an instance of this buffer class that we're going to write that holds, basically everything we want. The byte vector, the bit vector, and the low level implementation of the sequence in the stream.
Is there a difference between the byte vector that we're going to be holding in the bit vector, other than the fact that they're bytes and bits? Like, is it the same content except copied, or?
No.
Okay.
Bit IO is pretty complex, actually. It handles a lot of different cases, so it's not the same, no. Okay, so if you remember, we specified read bit sequence or whatever up there for the bits, but we have to define that.
Right. So we need to define.
So let's do a defun above that and define that guy.
Okay. Let's do a defun before here. Defun read bit sequence. It takes in the bit stream.
It takes in a sequence and a buffer.
Bit sequence and buffer.
And probably want to do and key and a start.
Start.
Defaulted to 0 and an end without a default.
Got it.
Yep. And that's going to call just a simple fast IO, fast read sequence.
Fast read sequence. Oh, okay.
I promise it'll get more interesting after we define this macro, guys.
So we read in the bit sequence.
Yeah, we read in the sequence and the buffer and start and end. That's all it is. It's just a light wrapper over fast read sequence.
All right.
BitIO knows how to read a read sequence-like function, and FastIO it tries to map closely to CL's read sequence and read bytes and everything like that. So this is just going to tell BitIO to use the faster read sequence rather than CL's read sequence.
Right. So
okay. So we got that. We just need to define our buffer class.
Right. So let's go ahead and define that here too. Def class buffer. I'm assuming that it's just going to be user defined. There's no subclasses that we're getting it from. So there's
right. It's just going to have just the 4 things that we make instance with on the bottom. Just with the args, no default init forms or anything like that.
Init args bytes. I'm guessing they're accessors.
Well, no, you don't even need them actually.
Okay.
We just need the init args because we're never going to be reading them directly.
Bits stream and sequence.
You know what? Let me think here. Just a sec. Okay, so I don't want the call sites to use the special variable. So I think we probably want to write our own, to answer your question, we probably want to write our own readers rather than put them in the class.
Okay.
So I would do a few defuns for like buffer bytes, buffer bits, buffer sequence, buffer stream.
Okay.
That way we can just call the slot value of our star buffer star, rather than use that special all over our implementation code.
Right. Do you necessarily
just a style of mine anyway?
No, that's fine. But I have a question. Then wouldn't you want to then just pass that into the macro directly as an argument, the buffer?
I mean, you can. I don't really like to though. I think I kind of consider the buffer to be like a low-level implementation detail that really shouldn't even be seen by the caller.
So buffer bytes just calls then slot value buffer on like this, I guess is what you're suggesting?
Yeah.
Okay.
Just like that. That way, whenever we need the bytes, we just call a function with no arguments. we're probably going to be doing that a lot, and using the special all over the place is just going to make it messy anyway.
Yeah.
Alright, yeah, that should be good for everything.
Alright.
Alright, that's probably good for
what we're doing now.
For that file anyway. Probably stick that in like a buffer file or something like that.
Yeah. Let me create a new...
That's literally all that's going to be in there for the low-level stuff, besides the actual readers that we should write first.
Okay.
Which are pretty trivial, actually.
So let me go ahead and move these guys into... the class and all this here.
So now whenever we need to read anything from the flex string, we just wrap it in with buffer.
So let me go and create...
That'll take care of everything, I think.
You know what? I'm going to be a little sloppy here. I'm just going to go ahead and say that this is in the same package. Just for...
And because it's a special variable, we really only need a with buffer like at the top of our... right before we start reading everything. We don't have to do with buffer for every read, actually.
Right, right.
That's kind of why I set it up like this.
Okay. And before I forget, I'm going to add that buffer into our ASD file.
Okay.
Because what I'm going to do is after this is all done, I'm going to go ahead and post this on GitHub for folks.
Sure.
Okay. Cool. And
okay.
Folks watching the stream, I just want to mention that I will do some cleanup on the packages just so that to follow kind of like Common Lisp standards. Right now I'm being a little sloppy for the sake of brevity.
So now we just need to define the primitive reading functions as far as like bytes and bits and strings and integers.
So read bytes. I guess these will all take in the buffer, right? Then yeah.
No. They won't need to know anything about the buffer. That's the whole point.
Oh, got it. Okay. So
so which one are you going to do first?
We'll start, I guess, with the lowest one, read bytes, right?
Read bytes. So we want to be able to specify how many bytes. So something like count or something.
Count. Okay. And then I think we'll do that call will be in fast.io, I guess. Or no, yeah, fast.io. Fast read byte, I guess.
For bytes, it's gonna be we gotta let bind the vector first. You see, fast.io needs an existing vector to write into, so we have to create an octet vector first. So do like let octet vector equals like, I think it's called fast.io make octet vector, and that takes in your count argument.
Yep, that's right. All right.
And then once we have that, we can do the cool thing is since we're using bit.io, we should use its read bytes rather than fast.io's read bytes, because that'll keep a buffer of all the bytes that are read, and that's kind of needed for when you get to reading bits. So we'll use bit.io for all the reading stuff.
Okay.
So it's actually going to be bit.io read bytes.
Read bytes, yeah. Okay.
And that's going to take in your reader function that you wrote for buffer bits.
So that's the first argument is read. Hold on.
No. Now go up to the top.
No, I have it in a different buffer. Hold on.
Oh, okay. So
Buffer.
I was going to say to put all that stuff in another file.
Oh,
up
okay.
Up to the macro, or down to the macro, and then these readers will be in another file called like primitives or something.
Oh, okay. I did not realize that. Give me a second.
It's kind of a different concept. That's like the low level stuff that you don't really need to pay attention. Like even the def bar.
Okay, got it.
Actually, especially the def bar, that goes with your macro.
Control V. What do I do? Go here. Put this here.
Yeah, then we just have like 4 or 5 primitive functions in that file.
Right. And add this guy also in there too, he said.
I mean,
yeah,
doesn't really matter, but
well,
I like to separate the concerns.
Yeah, no, separation of concerns is very important. So I'm just making sure that I put all the common buffer objects in the same location. That's actually,
now we don't even need to touch this file for probably the rest of the project. It's good like it is.
Right, buffer bytes, buffer bytes.
That's the low level crap.
Okay. So now this is buffer bytes.
No, it's buffer bits.
Oh, buffer bits. Sorry. Buffer bits.
It's going to take in a function call to your buffer bits.
Oh, it takes in the function call. Okay, never mind. So that means I have to do this. Okay.
Let me see what you got. No. It takes in a function call, not a function pointer. Yep. And that function call, remember, is just returning the slot value anyway.
Right.
So we're actually getting the bits out of our buffer instance. And then it takes in your octet vector. And let me see your call, your LDoc at the bottom. Okay, so we want to pass in the bits per byte thingy.
Bits per byte, yeah.
This is probably always going to be 8, so we might be able to get by hard coding it. Be 8.
And we don't have to specify bit endian?
No.
Okay.
No, we don't have to.
It's just odd that that's not, there's no default in there. That's kind of why I was asking. At least according to the mini buffer, there's no bit in. What the hell? Okay.
I think it sets that automatically.
Got it. All right.
Internally. No, we actually want to return. What do we want to return? Our octet vector.
Yeah. All right, and then we have to do the same thing, I guess, for read bits count.
Yep, and that's just going to be bit.io read bits with our buffer bits function call with a count. That one's simple.
So bit.io.
No, we don't need to do that.
Oh, we don't? Oh.
We just need to literally call bit.io's read bits function.
Oh. Read bits on buffer bits.
Yep.
And the count.
And it takes in your count. That's all.
All right. Defun read integer, I guess, would be something that we wanted to do.
Well, I mean, I I believe in the FLAC specification, everything is unsigned integers in big endian format, except for when you get to reading ag vorbis comments, because then you switch context to another format, in
Right.
which case you're reading little endian. So we actually do need little endian and big endian. So I'd call it like read uint big endian, or BE, and
Yeah.
read
Got it.
uint LE, or something along those lines to distinguish the two.
Okay. Read uint be takes in as a lambda list would be the well. I don't think we need to pass that. We just need to pass in how many integers we want to grab, right?
We want to pass in a byte count, I guess. Well, see, it's not really how many integers we want to read. It's how many bytes we want to read that make up the integer. So I would name it something different than count, like byte count, just to ease some confusion.
Okay, I'm gonna write this in the. So you're saying that we're reading.
We're gonna specify how many bytes make up this integer, and then we're gonna make an integer out of however many bytes we read.
Okay. I need to. I'm gonna put a to do here. Document function.
Okay.
So this way I can actually be able to give people like what this function actually does. Okay, so reading this guy, it will be an unsigned.
Well, luckily bit.io does all this for us. We just got to call bit.io's read integer function.
There is a read integer function. Ah, there is. Never mind.
And that's going to take our buffer bits.
And bits per
probably want to. There's going to be a lot of arguments, so probably do a new line or something.
Yeah.
It's going to take in. We want to do specify the byte endian keyword.
Endian to be BE.
Yes. And it's going to take in the num bytes keyword, and that's going to be our byte count. It also takes in the the bits per byte again. We can hard code that guy to 8.
You know what? I'm gonna go ahead and make that into a global. If we're gonna do this all the time, I may as well label that hard coded thing.
Well, specials are slow. I want to do that.
Really? How slow are they?
Well, they're dynamic, so I mean.
Okay.
They got to do the lookup of the value at runtime.
Great. Okay. Well, that kind of sucks, but all right.
Well, it's shorter just to type an 8. I mean, you're only going to have 4 of these anyway.
Okay.
It's not like we're going to be able to change them. It's not like you'd want to like lexically bind or dynamically bind a special to change them anyway. They're like hard coded. They're set in stone. So special really doesn't make much sense anyway, and it just all it's buying you is more code to type. Where did we leave off here? Okay, so did you do bits per byte?
Yes, I did.
8? Yeah, okay. And the last one would be unsigned P.
The default is set to true already, so are we changing that?
No, we're not.
Okay.
We don't have to specify it, but if you want to be explicit, you can add it.
Okay, I'll go ahead and do it just for the sake, but I just was wondering if we needed to specify that. Okay.
No, we don't. And that's it for that guy.
Now let's do the other one, which is
the
probably
other one's
the same.
Going to be exactly the same, no difference except the byte endian is going to be LE.
Right. All right, got that.
I mean, we could have wrote just a read uint function, and then at the call site of every time we want to do one of these, pass in DE or LE. But there's probably going to be a lot of these, so just to make it simpler, we'll do it this way, I guess.
We could literally make the uint function now, and then make these just at calls to that call. But I don't know how come.
Well, we can refactor later.
Right.
See how it goes. So the only thing we need to define, I don't think we need signed integers for this. I could be wrong, but I don't think we do. We'll add them if we need them.
Right.
The only other thing we need is string reading, which is the most complex one of them all.
Right. And read string. Don't know what the lambda list would be, so I have to go and look into this. String filling bytes, but if it's dynamic, it doesn't really.
What are you looking for?
Well, I was just wondering if there's like fixed string sizes, or if we're going to just have to specify a byte count.
Yeah, see, this is why it's a little complex. What we want to be able to handle is we want to be able to handle fixed string sizes, which is fine. We can pass in a byte count, so we get a fixed string size. But we don't want to do that, right, because we also want to be able to support reading until a null terminator.
Oh, so that means we'd have to specify a start and end, I guess. Right?
No, because we still want to be able to specify a byte count for the cases that we do. So we want that to be optional. So we want a keyword argument called bytes.
Okay. Bytes.
This is going to be able to handle both cases where we want to read a fixed amount of bytes, or read until either a null terminator is encountered or until the end of the stream.
Okay, so byte count, I guess.
And that doesn't have a default, but we also want an encoding defaulted to something like ASCII, because there's multiple different encodings that a string could be in, and we need to know that in order to decode it properly.
Is ASCII, I guess I can make that a keyword argument?
Yeah, it needs to be a keyword argument, because we're going to actually depend on the Babel library.
Right.
And that takes string or keyword arguments for its string decodings.
Got it.
And it also wants to take in something to specify whether it's null terminated or not. So like null terminated P or something along those lines.
Yeah. Defaulted to true, I guess.
No.
Oh.
No, because most of the time it's not going to be null terminated.
Got it.
It's going to be fixed length.
Yeah.
So the way this is going to work is, if we specify a byte count, it's just going to read that many bytes and then decode the strings that make up that byte. But if we don't specify a byte count, it's going to read until the end of stream, and then decode that into a string. Or we can specify a null terminated P, and it's only going to read until the null byte is encountered, and then decode. So there's like three cases that this could take.
Right.
End of stream, terminator, or a fixed length.
Okay.
So that's why this is pretty complex.
So I guess we could do a. Should we do a? No, cond is not a good idea. Maybe not.
Well, no. The first thing you definitely need is you need that octet vector like you got for read bytes at the top there.
Yeah.
Because you need something to write it into.
Hold on. Let me just go grab that guy.
It's going to be slightly different, though.
That's fine. You could change it. I just wanted to grab the signature. It's fast IO make octet vector, though, right?
I believe so. Let me go check.
Yeah, that's right.
Okay, I got it. So, okay, we need a function to be able to let's come back to this. We actually, we could probably do it in an F-let actually.
Yeah, that's
This
what
is
I
only
think.
going to be used by read string. So let's do an F-let above that let.
Okay.
No, above that let. Otherwise, you're going to be making a closure if we capture variables. Yeah.
You know what? I'll take this let out and add it back in later. Just
Yeah. Okay. Fine.
yeah.
So we want a function. I'd call it like string length or get string length or something like that.
Okay, get string length. And then it takes in as an
bytes and null terminated p.
Okay. And this guy would be like.
Oh, this one's a little complex too. Forgot how difficult string parsing was. Okay. So
we have to just keep finding until we hit a null, right? I mean.
Well, sort of, kind of, not really.
Got it.
IO input buffer vector, just like we did in that other file earlier.
It is input buffer vector. Okay.
And that's going to take in our buffer bytes reader. Okay, so now we have a sequence. Okay. Okay. So there's going to be a bunch of bindings in this platform.
All right.
We need to be able to find the maximum length, and the maximum length is either going to be the length of the sequence or the byte count that we pass into this function.
Right. So max length. Wait, you're passing in the byte count into this function?
Bytes or byte count, it doesn't matter.
Got it. So, wait. Yeah, we could do max length.
Well, I guess call it byte count because we called it byte count up above.
Yeah, I just want to be.
It's going to be a different binding, but it's meaning the same thing.
Right.
And that's just going to be or byte count null term. What is it? Or byte count the length of the sequence.
Oh, so you could just do max between.
It's just literally or, like whatever one is specified, basically.
Okay, got it. There, length and the sequence. All right.
Because byte count is when this is called, byte count could be nil because in our top level function, it's a keyword argument which defaults to nil.
Right. Okay.
So if it's nil, it's going to just take the length of the sequence, basically.
That's right. Okay.
So now we just need a start and an end.
Start defaulted to some number or just?
It's going to be a call to fast.io.
Okay, fast.io.
Fast-io.
Oh, yeah, fast-io.
Buffer position.
Buffer position.
Of our buffer bytes reader. Call.
Bytes reader. Okay, and end will be the length.
So it's going to get the start of the sequence. And end is going to be, this we could use min. Min is it's gonna be the min of the length of our sequence, or start plus max length. So whatever's smaller, our sequence size, or the total of start and max length.
Right.
If that makes sense. Okay, so we have the bounds of our string. Now we just need to check. We got to check if it's null terminated. So we need okay, one more binding. Call it like index. And that'll be if null terminated p. By the way, it's good practice to name your predicates with a dash p if it's multiple words. Minor style nitpick.
That's fine. But that's a very good that's a good practice that I need to start following.
No, you want an if actually.
We do. Okay. If null
terminated p.
Terminated p.
Well, the else branch is just going to be end.
Okay.
We'll do the middle branch or the first branch last. We could just type an end and then close that up if off, and then just fill in the middle there. The middle is going to be a little more.
Right.
Let me think about that one. So it's going to be
if null terminated. That means
we want to use position.
Yeah, that's right. You want to find where it is.
We want to find that 0. So position 0 in our sequence.
Buffer bytes.
The start and the end.
No.
Our
Sorry.
sequence.
Our sequence, sorry. Yeah.
And then start. Start is start, and end is end. That should do it. This is a little complex function. It's been a while since I wrote this, but it should make kind of somewhat sense. See.
So now what we return is going to be the.
What you return should just be the difference of index and start.
Yeah.
So minus index start.
Okay. Here's our float. Now we need to create our octet vector here, which is.
Luckily, this is the last primitive function we need to write.
Octet vector. Oh, dang it! I did it again. Sorry.
So this is actually going to take in, for the argument to make octet vector, it's going to take in a call to your string length function.
Get string length.
And this is to figure out how big of a vector we need to pre-allocate to write into.
Byte count. Null terminated p.
Yes.
All right. Actually.
Yep. Yeah. Exactly. And okay, so we have a vector with the right size that we want to write the bytes to a string into.
Right.
So now we need to read those bytes. So, which is going to be fast IO, fast read sequence, and it's read sequence because it could be more than one byte.
Fast read sequence. Okay, that's taking our sequence, which is our buffer byte.
No, our octet vector.
Our octet vector.
It takes in the output first.
Yeah, that's still getting used to. I have to get used to that.
The second argument is the input, and the input's going to be actually a call to our buffer bytes reader.
Right. And then start is already 0.
So that function's side effecting, so we don't need to bind it to anything. It's actually writing into our octet vector. And then after that, what we need to do is check for null terminated. So when null terminated p. Wait. What are you doing?
Well, the optional starts with fast IO start and then end.
They're perfectly fine. We can leave them.
Okay, got it.
We want it to start at 0.
Then when null terminated p.
Okay, so when we specify that it's a null terminated string, we want to pop that extra byte off the stream basically.
Got it.
So we just need to make a call to fast.io, fast read byte. We're gonna throw it away. We're not gonna use it, but we need to get it off there.
Read byte. Input buffer is going to be our octet vector.
It's going to be our buffer bytes.
Oh.
No, our octet vector is only for our temporary storage. What we're going to return. That's new memory. We want to be reading from our actual stream on disk, which is our buffer bytes reader.
Oh, so we're stopping until we hit the null termination, and now we're just eating this.
Yeah, we're eating it. We're getting rid of it. That's all we're doing here. Like, we're not even going to use it. We're just throwing it away.
I thought the fast read sequence includes that that null termination character. So
no, it doesn't. We might be able to fix it so it does.
It's fine.
It'd be pretty complex because our get string length function is kind of trying to figure out the length of a string, whether it includes, like, it'd be kind of messy to do that because we don't know if it's null terminated or not.
Right.
Inside of get string length. Well, we do, but just in the index part, we only know that. We don't know it in the subtraction part. So we'd have to do like a couple more lines of code. It'd probably get messy. It's already pretty messy. I don't know. I haven't thought about that. But yeah, we just want to eat it for now.
Okay. So fast read byte.
That's good. So we just got to make one more call here to actually. So at this point, we have our bytes that make up the string inside of our octet vector that we let bound. They're already written in there from the fast.io fast read sequence call. So now what we have to do is we have to decode it into a string. And in your REPL, you might want to quick load Babel and then add it to your depths. It's a good library for working with strings and decoding them and everything like that.
Give me a second.
Different languages, encoding, stuff like that. I've only used it personally for decoding strings like this. I know it does a bit more, I just don't know offhand what it does.
Okay, got it. And now that we have Babel, we do Babel, let me see. We're going to have to specify the string encoding in here. So which one would it be? Octets to string, I think, right?
Yep.
Oh, I don't need to do that here. I can just get out of this one. Okay.
Yep. And
okay.
Do you know what the rest of it's going to be?
The vector is going to be the octet vector. And our encoding is going to be specified in... Oh, there it is. Encoding. And did I specify it as encoding? Yes, I did. Okay. I think that's it, right? Yeah, I think that's it.
That's it. That's everything we need to read a FLAC file with. I'm pretty sure, anyway. So we got bits, we got bytes, we got little and big endian unsigned integers, and we got strings. Here we go.
Sorry, I had a typo in my code.
Null terminated PN somewhere.
Yeah, I found it. It's because when I'm going through with Emacs very quickly, sometimes I just accidentally hit that. Okay. So we now have our functions to actually being able to read everything. Now we have to actually define.
Now it's writing the FLAC parser.
Yeah, we have to write our FLAC parser. Now, let's see here. Do I want to rename this file? Since these are a bunch of... This is not really the main code.
What are you asking?
Yeah, I'm just thinking if I should go ahead and move this around. I'll do this later. I'm just going to put a to-do here. move
Yeah, you can stick that in like a primitives.list file or something like that.
into a read primitives.lisp. Okay, got it. All right, so now we're going to actually start with our FLAC parser.
Yep.
All right.
Okay. Well, we got a few minutes left anyway. We can run a couple minutes over late. We could probably just get the basic loading of the file and take a minute or two.
Right.
So when you read a FLAC file, you have to decide whether you're reading from a file on disk or you're reading from maybe some stream that already exists from some other library, like maybe it's an in-memory stream or something. So you kind of want two APIs, one for reading a file and one for reading a stream.
Right.
The file one can actually call out to the stream one.
That's right. Figured.
And that can do most of the heavy lifting because, you know, the file one would just basically be with open file.
Yeah, right.
And then it would have a stream already.
So we could just do something like read file with the file path, and then do with open file stream our file path, and then all the other ones kind of stand. We don't need to specify any of the other options because we are actually just reading it. We're not writing it, and then we could just make a call to read stream on this guy.
Let me see here. That's a little wrong. Because when you're reading from a file stream, you need to specify that it's an unsigned byte 8 stream.
Oh, give me a second.
You do have
Element
to pass
type.
in the element type after the path there.
Right. Unsigned byte 8.
Yep.
Okay. Got it.
And then it just calls read stream in path. Yeah. No, that's wrong. Read stream takes 2 arguments. You got to pass in file path as well. Oh wait.
No, because we've already read in the file here, right?
Oh, hold on. Well, it depends. Do we want to, like, when we create an instance of our FLAC class that we'll eventually write, do we want to store the path? Because if we do want to store the path as a slot in that class, then we need to pass it to load stream.
That's right. Okay.
Because load stream is going to be actually creating the instance of that class.
Got it.
That's where my confusion was.
Okay. And let me rename this to being specific, just so that it's not generic enough here. All right. Read FLAC file.
Yep, that's all you need to do for that guy. The big guy is going to be load stream or read stream.
Read FLAC stream with the stream in hand.
Well, not too big.
And the file path, and then what this will do is, I'm assuming at some point we're going to actually create our FLAC class in here.
I would make file path an optional argument because it might not have a file path if it's like already an in-memory stream.
True. Okay.
And that's going to start out with our with buffer macro.
And our macro will take in the stream. And,
Keyword.
Sorry, stream is a stream. And
yep.
Our sequence is...
We don't need to do the sequence for this one.
Oh, okay.
The only time we need to do stream is our initial thing here when we have a stream. Because if you remember, our macro is going to take care of creating the octet vector automatically.
Right. That's
from
right.
that stream. So, yeah.
So now that we have the stream and it created our octet vector.
Now we just create an instance of our class that we haven't written yet.
Make instance FLAC. I guess, metadata. We need to specify the
we don't need to specify anything because that's basically going to be set up from other parts of the parser because we're not even there yet.
got it.
So we just need to return that that flag metadata instance.
That's what I'm doing.
Oh wait, no. We actually want to let bind that.
Oh, let
Because
bind.
we're gonna put stuff between making the instance and returning it.
Oh, got it. Okay.
And that's gonna be the parser area.
Flag metadata.
So it's gonna create an empty one of these instances, and then it's gonna do some parsing, and then it's gonna return it basically.
Then we return this guy. Like that, right?
Yeah.
Cool.
And that big comment is probably next stream.
Yeah, that's going to take a while. So, folks, I will go ahead and post this so that you guys can also start hacking away.
Good news is that's all the boilerplate. We don't really have to do any more heavy lifting.
And then next stream, we're going to start actually building up the parser. So come next week, and if you guys, check out the structure, and hopefully, we'll have a working parser for our FLAC metadata, and we'll go from there. I'll see you guys next week.
All right, bye then. Thanks.
Bye.